Hi guys, welcome, and today in this tutorial we will go through UART serial communication. So we will see how we can use the UART port to communicate. So mostly the UART port is used to see the debug log output on the PC. Okay, let's see how we can use the UART serial communication. So first of all, let's go through some of the theory. This is the basic structure of a UART communication packet, and we have a start bit, and then we have some data bits. Mostly there are 8 bits of data, which is a single byte, and then there is a parity bit, which might be 0 for even, 1 for odd, or maybe the parity. There is no parity, so none would be the parity. There are some stop bits. We can use 1 or 2 stop bits for that, and this is a single frame or a single packet of the communication. So normally we use the baud rate for this communication is 9600 bits per second, and also we can use 115200 bits per second. These are the most commonly used baud rates, and this is asynchronous because the clock is not synchronized between both of the devices. So each device has to generate its own clock. So this is called asynchronous communication. If we use the clock, if we use the same clock source to synchronize our messages across the port, then we will call this as a universal synchronous asynchronous receiver transmitter. Normally we don't need to use the synchronous communication, so we will use the asynchronous communication. So in this method, our clocks are generated on the each end by the devices. So that clock is basically the baud rate we mentioned. So the next thing is how we connect with the other microcontrollers. So keep in mind, TX pin should be connected with the RX pin of the other microcontroller, and the RX pin should be connected with the TX pin of the other controller. And since it's a serial communication, so all the 8 bits of data from bit 0 to bit 7 is transmitted serially over a single wire. The data transmitted from one device is on the TX pin, and it's received on the RX pin of the other device. And since it's a serial communication and it's not a parallel communication, so it's going to take longer, 8 times longer than the parallel communication. So in order to connect our UART with the PC, we have to use some converter which can convert our TTL logic. So we will use a serial TTL to USB converter, and this would take our TX and RX pin and the ground pin from the microcontroller, and it's going to transmit this data over the USB, and the USB is connected with the PC. And so on the PC we can use a serial application terminal like putty for our sessions, for our serial communication sessions, and we can see our data on the serial terminal. So it's really useful. We can use it for debugging purposes, and for displaying data, or for communicating with the device through our PC. Okay, I think so we have enough of the basics for the UART communication, so let's start coding. So first of all, we will create a new project. So go into PC and the Windows C directory. Here we have the nRF SDK, and we go in the examples folder, and we are going to go in the peripheral. Here we will have to find UART, and we will copy this folder to our projects and paste it here, and let's rename it as UART tutorial. So let's open this. We go into the PC of 10040. Our microcontroller is 52832, so our board is this, and go into the blank Sagar Embedded Studio, open the EM project file, and here we go. We have opened our project, and first of all we will remove all of this extra code. We don't need this. We'll remove everything for now. Let's delete everything because and of course we will remove this and this. Okay, why I'm using this UART directly, because it has already configured the SDK. So if we go into CMSIS configuration wizard and we go in the drivers, and here if we go in the UART enabled, and you can see it's enabled. So basically it has done all the configuration, so it's very easy to start from here. So that's why I use this as our base project. And if you want to use the template project, you can use that, and then you have to configure this UART. So first of all, we have to define the buffer size for transmission and receiving, because we are going to use the FIFO library from the Nordic, and it's going to be very helpful. So let's start. So first of all, we are going to define the TX and RX buffer sizes. So hash define UART TX buffer size. This would be, let's give it 128 bytes. Let's define the RX buffer now. Hash define and this should also be 128 for now. Okay, so the next thing is we have to create a constant for hardware flow control. Basically we don't use the hardware flow control unless we are using very high baud rates, so we will disable that. To do that, we have to define a simple constant. This constant would be passed to the function in the later code, and we are going to use this flag from the API, which is flow control disabled. So this is the flag, and we use this flag to say that we don't need the hardware flow control, because we are not going to use a very high baud rate, and we don't need a synchronous communication. Okay, so the next thing is, before creating anything, first of all we have to create a error handler. So it's going to be something new for you guys if you are beginners. So the error handler is basically a simple handler. If some error occurs, it's going to go into that function, and it's going to tell us what went wrong with our code. So we need this error handler for our function. So first of all, I'm going to create a error handler. So let's give it some name, UART error handle, and here we are going to use event type T, and let's create the pointer, and that's it. For now, as for beginners, just leave it empty. If later on you can see the main example code from the same UART, and you can implement that, but for now I think so you don't need to push yourself too hard with this code. Just if you are a beginner, just go with the simple code and try to play around until you get confident enough to play with all of the stuff. So in the later tutorials I will be explaining about the interrupts and all the different stuff. Once you go through the interrupts and events and everything, then you will be easily able to grasp the concepts about this. So first of all, we will declare an unsigned integer 32 variable. So it's going to be, and let's give it a name as error code, because this is going to be used in the functions. So first of all, let me explain a little thing that might be new for some of the guys who came from Arduino background. So here, this is the common method. Let me write down the code first. So this is the common method, and you use your functions here. For example, error code equals your function. Okay, so basically what happens is, in the SDK, this is the SDK's way to handle the errors. So once you declare the error code variable, you start a function and assign its value to error code. During the execution of the functions, there might occur some errors, and if an error occurs, it's going to assign that error code to this variable, and then this app error check function is going to see if this error code is one of the predefined errors, and if it occurs, all of this code is going to get stopped, and it's going to stay on that error, and it will let you know on the debug session. So it's really useful way, because we can directly approach the error from this way, and we can remove it from our code. We can see what are the flaws in our code, and we can deal with them easily. So first of all, we are going to initialize all of the LEDs. So we will use the BSP board init. So in this parameter, we will use the LEDs flag to initialize all the LEDs. So the flag is BSP init LEDs, and this is going to initialize our LEDs for us. So we can just turn on and turn off any LEDs on the go. So the next thing is, we have to create a constant app UART com parameters type T structure, and give us a name com parameters, and now here we have to assign the pins. So first of all, the RX pin, basically this is the UART RX pin, and if we right click on this, go to the definition, and we can see it's the pin number 8, and the TX pin is pin number 6. On my board, they are connected with the CH340 USB to UART converter. So it's basically going to be connected with the PC, and we can see our stuff on the PC. So let's write down our code first. So the next pin would be TX pin number, and then we have to give RTS pin number, then we will give the CTS pin number, and then we have to give the hardware flow control, which is this, and then we will use the parity. For parity, we will use false, which says no parity, and then we will define the baud rate, and for that we will use the flag, and we will use nRF UART baud rate, which is going to be 115200, and we close this. Okay, so we have defined the pins and the baud rate. Now we have to pass it to a function, and our function, and we are also going to pass this error code to our function, and if during the initialization, if some error occurs, this function is going to check that error, and it's going to tell us if something went wrong or not. So for that, we will use the function app UART FIFO init. First of all, we are going to pass the address, then we are going to use UART RX buffer size, and then we will pass UART TX buffer size, and the next thing is the function error handler. This is going to be passed. Make sure only you pass its name only. Then we are going to give it a priority, and for now we will give it the lowest priority for now, and we will later on in the later tutorial series we will see how we give the priorities to interrupts. So basically this FIFO is an event and it has some interrupt we will see later on. For now just go with this simple code, and we will give the error code, which is this, and that's it. Our initialization function is given, and now we are ready to use the UART. If everything goes okay, we can use the UART port now. So first of all we are going to use simple printf function to print a message on the screen. So let's say hello PC. And put the escape sequence there, and it's good to go. Also I want to read a character from the PC, and it's going to turn on an LED. So for that I'm going to use a simple unsigned integer 8, and let's give it the name as CR character, and then we will use a function which is app_UART_get, and here we will pass the address for the character, so it's going to save our value in that character, and we will wait until the character is read, and if it's read then it's going to pass this flag which is nRF success. So it's going to wait here until it receives a character from PC. And the next thing we are going to do is, let's see what character we have received. If CR, let's tell if it's T, turn on the LED. Make sure you put the character in the single quotes, and here we turn on the LED, so BSP board. We turn on all of the LEDs, so BSP board LEDs on. We also print a message on the screen, so printf. Let's print the message that LEDs turn on, and put the escape sequence there, and then we can also check if we have received a character to turn off the LED. So to turn off the LED, let's say K is to turn off the LED. So we use the BSP LED off, LEDs off, so it's going to turn off all of the LEDs, and we also need to print LEDs turned off. Okay, so we are done here, and Control plus S to save, and let's build the code. Okay, once the code is compiled, we will go in the target, connect with our device, erase all, and then we will download our code. Once it's downloaded, we will open a terminal and we'll see our UART port is working or not. So first of all, let's see what port is connected with the UART. So I'm going to right click on this PC, go in the properties, and then go in the device manager, close this, and on the ports, see which port is connected. So on my device, on my PC right now, the COM11 is connected. So I'm going to open the serial terminal putty and click on the serial, put the COM port here 11, and let's set the baud rate to 115200 and open the port. Okay, the port has been opened, and right now we just see some different characters. We will have to reset the terminal. Okay, and let's reset the device as well, because it already transmitted it previously, but we didn't turn on any terminal, so we couldn't see the message. So right now we have opened the terminal, and we can see the message has been received, and it says hello PC from Nordic device. So let's turn on and turn off all of the LEDs, and to do that we remember that if we send a character T, it's going to turn on all of the LEDs, and if we send the character K, it's going to turn it off. So I'm going to press T, and here on the terminal it says LEDs turned on, and as you can see all of the LEDs are turned off. And if I press the character K, it says LEDs turned off, so all of the LEDs are turned off. So I can control these LEDs from my PC by just sending some characters from my keyboard over UART port, and I can turn on and off these LEDs. I hope so you learned something new today, and please be sure to subscribe to my channel and hit on the like button if you like this video, and thank you very much for watching. See you in the next video.